Hi guys, in this video I cover structures, often named just structs. Structs are higher level data types that are created by a programmer. These custom data types can have any number of variables of different data types in them. They are used to model higher level concepts. Let's take a look how this works. It starts out with a struct keyword, then an identifier. Now often it's used starting with an uppercase letter, but older code often uses identifiers that start with a lowercase letter. Then there's a code block with open close braces and a semicolon. Don't forget the semicolon here. This marks the end of the definition. Now, this is not a code block where we define any kind of functionality. It's really a code block where we define variables. These variables are called member variables or properties or fields. All of these refer to the same thing. Now, I model a person here. So I add and define the variables that make up a person in my program. In this case, I want the person to have a name. So this is a string and an age of type int. And these are all the variables I need. There's no limit to the number of variables that a struct can have. We could have 0 variables or 100. Now, it's important to note that this really is not a code block. It doesn't execute. There's no functionality. It's really just a definition of member variables. And this is a type. That is, it's a blueprint. Similar like an integer. An integer is just a type until I declare a variable of that type. So for an integer, I define the data type and then an identifier. This creates an instance of an integer or an integer variable. Now similar to a struct, but the struct I have to prefix with the struct keyword, then the type, which is person, and then an identifier. In this case, I use the identifier John. Now, with this instance of the struct, I can access the member variables. And I access them with the dot operator. So John dot, and then I can access name and age. In this case, I want the name to be John. John also has an age, so I do John dot age, and I say his age is 20. Now, this is a single instance, or sometimes called object, of the struct. I can also create another person, another instance of the struct using the struct keyword, person, and I call this Mary. And Mary also has a name. Her name is Mary. And Mary has an age. Her age is 22. Now you can see I can create any number of instances of this type. And important is that the name here and the name below are different variables. When I assign John to name up here and Mary to name down here, they're completely separate. I don't reset, I don't assign, I don't change the value of name. Similar with the age. These are different variables. So each instance of the struct gets its own set of variables. I will now show you how we can pass a struct to a function. And in this function, I will output the variables. So we can see that they are different for each instance. So up here, I define my prototypes. The first prototype is named print, and it expects an instance of person. And then below the main, I implement this function. Print struct person p. And here I use printf to output the name and then the age. p.name and p.age. Now I access name and I access age, and these will be placed into this template here. In the main function, I can now call this and pass in John to it. So John is the first instance of the struct, and then I pass in Mary to this function as well. Now running this program, you will see that I have John, the age is 20, and Mary, her name is Mary, and the age is 22. So this confirms that these variables are different for every instance. Again, this one up here is just a template. Now let me show you how we can deal with pointers. Now I declare a pointer to a person struct, or PTR, and I point to John. So this gets the address of John, and I store the address in this pointer. So this one here is a pointer to a struct instance. Now I want to update the name. I want John to no longer be named John, but to be named Steve. So I follow this pointer using the dereference operator, then use the dot operator to access the member variable. And here I assign Steve to it. More commonly, you will see a different operator. This is the arrow operator. PTR, arrow, and name. So arrow works when this variable is a pointer. It follows the pointer and accesses the member variable. Both of these can be used interchangeably. They're exactly the same, just the syntax is different. And this one is typically much cleaner, so you will see it more common. Now, if I print out John again, what will be the output? The output will be Steve, because here I used the pointer that points to John, and then I renamed the name variable and I store Steve in it. So I renamed John to Steve. This is not a separate variable, it's really just a pointer to John. Now I can do the same thing with a function. So if I add update here, person pointer p. So this now expects a pointer. And below the main, I implement this void update struct person pointer. And here I update the age. This is a pointer, so I use the arrow operator to access the age. And Steve, or formerly John, had birthday. He's now 21. And then I call this function in the main. This is called update. And I can either pass in the address of John using the address of operator, or since I have a pointer already to it, I could also pass in the pointer. The important thing is that this expects a pointer. And now if I print John out after this, he should now be 21. Here you can see he's now 21. So to reiterate, I have a struct with member variables. Important at the end of the definition is a semicolon. I declare two instances of the struct. Each instance has its own set of member variables. Then I use a pointer to the first instance named John. I update the name. I pass the John object to a function that expects a pointer, or I can pass the pointer to the function to update the age, and then I print it out again. I hope you enjoyed this video. Thank you for watching.